graphs. Just what are graphs, and how do we find information from them? In physics, we have three types of graphs: distance versus time, velocity versus time, and acceleration versus time. In these three graphs, we can do several things. We can find slope, or we can find area. And each one means something different. When you have a distance versus time graph, and you find the slope of that, we call that velocity. An area graph for distance versus time, we do not do. That is something I will never ask you to do. Then you have your velocity time graphs. The slope of a velocity time graph is your acceleration. Okay? Now, the area under the curve of a velocity time graph is distance. This will always give you the distance or total displacement traveled with a certain time. The next type of graph we have is acceleration versus time. The slope of an acceleration versus time graph is something you will not be doing. However, you will be finding the area under the curve of an acceleration time graph, and that area under the curve is known as velocity. If you notice something, the slope of a distance time graph is velocity. The slope of a velocity time graph is acceleration. Then you have the area of an acceleration time graph is your velocity, and the area under a velocity time graph is your displacement or distance. So there is a relationship between all of them, and that is a mathematical relationship we will explore further in a couple days. But for now, we are just going to look at these graphs and determine how we find that information. So, for our first one, it is a distance time graph. And if we look at it, distance time graph, we find the slope. Okay? Slope is, we know, rise over run, which is the change in y over the change in x. So we want some spots that cover where our graph divides it up nicely. And I am going to choose right here and right here. So we have 0, 0, and 3, 3. So we know our rise over run is 3 minus 0 over 3 minus 0. That gives us a 3 over 3, which is 1, and then units of meters per second. So that means for every 1 second, it goes 1 meter per second. That slash means per. So, what else can we tell about this graph? Well, because that line is linear, it is constant velocity. That means it's not changing. Now we have a velocity time graph. We can find several things from a velocity time graph. One of these is slope. Again, slope in this case is going to be acceleration. Okay? It is rise over run. Now we want to find 2 points that cross our line. It doesn't really cross that line quite nicely. It does here at 3, 4, but no place else. One way you can do that is to extrapolate that line on out and see if it crosses anywhere else. And it looks like it doesn't. So the other spot we can use is our 0, 0. So back to 0, 0. And we have a 4, 4 point. So our rise over run is 4 minus 0 over 4 minus 0. So that gives us 4 over 4, which is 1 meter per second, which is the same thing as 1 meter per second squared. Okay? Meters per second is the same thing as meters per second squared. They are velocity divided by time. Now the other thing we find is the area under the curve. And we are going to find the displacement at 4 seconds. So how far has it traveled in 4 seconds? So we draw. So we're wanting this right here. The area of a curve, that's a triangle. The area of a triangle is 1/2 base times height. So we know that's 1/2. Our base is 4. Our height is 4. So that's 1/2 times 16. So that's 8. Okay. Our units are meters. Displacement is a measurement of distance, if you want, and those units for this is meters. Our next graph is an acceleration time graph. We do not find the slopes of those graphs, but we do find the area. So area, this is a triangle. Let's say we find the area at how far it's went in 5 seconds. So the displacement at 5 seconds. So our 5 is right here. So this is what we're looking for. Now notice it doesn't cross the line, so I'm going to estimate. And I'm going to say that's about 4.5. Okay, so we know 1/2 base times height is going to be 1/2 of 5 times 4.5. So this is now 11.25. Now we're dealing with area under an acceleration time graph. So we have meters per second divided by seconds. So that takes care of this second and this second. Gives us a velocity. So its units is meters per second. So that object is traveling at the 5-second mark 11.25 meters per second. Now this is a strange one. This is a velocity time graph. We know here it is constant, so acceleration is 0. We know there is an acceleration here, it's positive, and we know there's an acceleration here. Okay, but what else can we find? Can you tell me the displacement at 10 seconds? So here's our 10-second mark. So we're wanting the area that looks kind of frightening. But we can break it down into parts. Here's the first one. Then we can do this one. This is 2. And this is 3. One way to do it is to count the squares. But how would you estimate that square right there? Right above my 3. That would be kind of hard. Another way is we've broke it down into sections. Go ahead and find the areas for each section. So for section 1 would be 1/2. Since this is a triangle, base is 3. And it's went up to 0.4. So 1/2 of 3 times 4 is 6. And our second part, we're going from 3 to 10. So, and this is a square. So it's base times height, which is 7 times 4, which is 28. And then our third section is another triangle, which is 1/2 base times height. So it's 1/2. Our base goes from 7 to 10, so that's a change of 3. And our height is going from 4 to 8. So that's a change of 4. So 1/2, 3 times 4, which is 6. So now you add everything up. So the total would be 6 times 28 times 6, or 6 plus 28 plus 6. So the total would be 40 meters. So the total displacement at 10 seconds is 40 meters. Now we have something a little bit different. We have a distance time graph. Okay, we can find the slope of this distance time graph. Slope of a distance time graph gives us velocity. So let's find our velocity. Let's find a spot where it crosses and it doesn't cross someplace easy. So let's kind of extrapolate that out and see if we get anything. I'm going to go with, it looks pretty close to what? Let's say in all honesty, it looks like it's going to cross right there, which would be, see, 10, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So right here is 13. And over here, 10, 14, 16, 18, 20, 2, 24, 26. So our rise over our run for this one would be 13 minus 0 over 26 minus 0. So that is 13 over 26, which is 1/2, or 0.5 meters per second. So if I say this is 1, this is 2, then we know at 0.5 meters per second is our velocity. It's constant, so it's not changing. So that would be a straight line right in there at 0.5 meters per second. Okay, so now this velocity is not changing. So is the object accelerating? No. So acceleration would be 0. So the acceleration would be along the 0. Now this one is a little bit different. We have a velocity time graph. We know we can find a displacement, and we know we can find an acceleration. So let's find the acceleration first. You have acceleration is found from a velocity time graph by finding the slope of the line. So we're going to go right here and here. So at the 0, 0, 10, 12, 14, and 10. So we have 14 minus 0 over 10 minus 0. So that's 14 over 10. So that's a 1.4 for acceleration. So if this is 1, this is 2, we're going to have an acceleration. And by this line not changing, that means our constant acceleration, and it's going to be about a 1.4, so just a little bit below that 1.5 line, you have an acceleration of 1.4. Okay, now let's find our displacement. We're going to find it at 2 spots. We are going to find it at, let's say here, at 4 seconds. And then we're going to find it here at 10 seconds. So at 4 seconds, triangle, 1/2, base is 4, height is, go ahead and roughly call it 6. We're estimating on this one. So that is about 12. See, 4 times 6 is 24. Half of 24 is 12. Then at our next one, it's again a triangle. 1/2 base is 10. And it goes up to 14, which is 140 divided by 2. See, and that would be our 70. So we know our first spot, it will be at 12, and our second one will be at 70 when it's at 10 seconds. So our graph 2, 4, 6, 8, 10, 10, 20, 30, 40, 50, 60, 70. So at 10 seconds, this is our 70 meters, we have a spot. And then at 4 seconds to 4, we are at 12. So we have another spot. And we know it's going to be a curve. So it will look something like that. So from that velocity line, we can find acceleration and we can find displacement.